Hello, everyone. My name is Katie, and welcome to another edition of Data Center Insights. Before we dive into today's great webinar, I would just like to point out a few features of the BrightTalk tool for you, our live audience. There is a questions tab at the top of your viewer. I encourage you to please ask questions anytime. Our presenters will be more than happy to answer them for you at the end of the presentation. Also, at the end of today's webinar, you will be prompted to rate the presentation. Please feel free to take the time to provide feedback, as we really value your thoughts, and we will use this information to improve our future webinars. If for some reason we don't get a chance to answer your question, or if you have any suggestions for other webcasts that you'd like to see, you can share them with us on our Twitter channel at Intel IT Center. There's also an Attachments tab where you can find supporting documents for today's presentation. Please feel free to download today's presentation, find links to some academic papers supporting our presentation, as well as links to some other great blogs and podcasts that we've done with the good folks over at Netflix. These attachments will be available to you shortly after the webinar ends. So today's webinar episode is entitled Netflix, the Journey to Efficiently Securing Your Video Stream, with our fantastic presenters, Jonathan Stern, Applications Engineer here at Intel, and Scott Long, Senior Software Engineer at Netflix. Today, Jonathan and Scott will be discussing a challenge Netflix faced to protect the privacy of their customers while serving over a third of all internet traffic in the U.S. They will discuss solutions that Intel and Netflix came to, as well as details of the analysis performed and the outcome of this great collaboration. It is truly wonderful to have you all here today, and with that, I'm going to hand things over to our presenters, so go ahead and take it away, Jonathan.
Thank you, Katie. So, as Katie introduced me, I'm Jonathan Stern, and I'm an Applications Engineer here at Intel. And what we're going to talk about today is, I think, a really interesting story. And the reason that the story is interesting is that there's a few reasons. The first is scale. The scale at which this Netflix team had to develop and deploy this particular solution to a big challenge is kind of unprecedented. It's on the giant end of the scale. Second is openness. Because Netflix as a team is very willing to share their learnings with everyone. They've really done a tremendous amount of hard technical work, but they are in the wonderful position to be able to share that hard technical work with us through blogs and webinars like this one. Finally, I think the thing that's really tremendously interesting that a lot of people might get a lot out of is the actual business outcome for Netflix as a company. And we can't put too much detail on that, but we can put a little bit of scaling on how much this meant from a business perspective to Netflix. Now, to talk through all of these things, I'm going to introduce my co-presenter, Mr. Scott Long from Netflix, who is a senior software engineer at Netflix and really, in a sense, led the team that did this work. Scott?
Hi, Jonathan, and hi, everyone on the call. Thank you very much for the kind introduction. As Jonathan said, my name is Scott Long. I've been with Netflix for coming up on 5 years now as a senior engineer working on the OpenConnect platform. Our team is about a dozen software engineers, and our department's about 100 people that work on this whole delivering video over the internet project that we have decided to tackle and try and be successful at. So to give you an idea of what we're doing, I'm going to start with this graph. It comes from data from Sandvine on internet traffic in North America. And right there it jumps out at you. We are 33% of the North American internet traffic during peak times. That translates into we're streaming over 35 terabits a second of data worldwide. We're streaming it to over 86 million subscribers. And we're doing it via hundreds of partners. And I'll explain how that partnership works and how this all streams out and how it's architected here in just a second. But it also goes back to we're a very small team that does this, and relatively speaking, like I said, only a few dozen engineers, and really what it comes down to is that at core, we're not a tech company. We're an entertainment company that uses technology. So in order to facilitate that, in order to be successful at that, we really need to focus on sharing, like Jonathan said. So that's one of the reasons why I'm here today to talk about this, is because we really like to share the technology that we're using, because we want everyone else to use it so that it builds this fantastic ecosystem and builds great partners. So back to the architecture. We use Amazon Web Services for a lot of our infrastructure, and there's been a lot of talk about that in the media and on blogs and all that kind of stuff about how Netflix is very centered on Amazon Web Services for our infrastructure. And that's absolutely true for everything from our website to our business backends to our recommendation engine to encoding the bits into different formats. That all happens on Amazon. But once you press play on a movie that you want to watch, all that switches over to our CDN, our content distribution network that we've put together. That CDN is a project that we've been working on for about 5 years. We've been doing video delivery over the internet for almost 10 years now, and we've been doing it via third-party CDNs. But about 5 years ago, we made the decision that we wanted to control our own destiny, that we realized we were going to be growing faster than what our partners could accommodate for us. So we started working on our own CDN that we call Open Connect. This has allowed us to build this worldwide network of video distribution using some of our own resources and data centers, using ISP partners that we embed our caches in, and using the interconnects between them to move the data. So with being at the scales that we're at, we're also facing new challenges. Big one is the industry is going towards 100 gigabit interconnects in the data centers, and how do we take advantage of that? The second is that with all this massive build out and growth that we're doing in terms of serving, how do we encrypt that? Because what we found, we've always been encrypting our backend communications. When you talk to the website, when you give your credit card, and all that kind of stuff, that's always been encrypted. Very industry standard type of thing. But what we realize is that it's also important to encrypt the video data on a per user session as well, so that your privacy as a watcher is protected, that no one can snoop and see what you're watching. But that is a huge computational problem that for a long time we thought was not going to be solvable, that we would just have to live with the status quo of not being able to encrypt. But we decided that we would try it anyway, but we had to figure out how to do it cost effectively. We couldn't just throw money at this problem. We couldn't just go out and replace all our existing infrastructure around the world with new super beefy systems that had the horsepower to do this inherently. We had to continue to use our existing systems, augment them as necessary, but keep it cost effective in all those respects. So before I get to the solutions on how we met these challenges, I'm going to step back for just a quick second and talk about our hardware and our software. So, like I said, we have our own network that we built out around the world using basically Intel PC class servers that are commonly available. Supermicro motherboards and industry standard hard drives, all that kind of stuff, in very common chassis. This is separated into 3 categories of servers based on the use. Our first category is our storage server. That's our kind of our library server that holds a large fraction of our total video library. They're stacked together to create copies of the full library placed strategically around the world, and then fractions that are placed inside of ISPs to help accelerate access to the data. Those machines are typically connected via 10 and 20 gig links, and they're primarily spinning drive media. So anywhere from 100 to almost 300 terabytes of data in them. Our second category is our flash appliance, and we call it flash because it's all SSD-based flash, and it's meant to hold a small fraction of the library, the most popular content that is really hot right then. Those are also placed strategically where they can serve a lot of customers in parallel, and those take advantage of the higher speed network links, the 40 gig and now 100 gig links. And then our third is a global appliance that's meant to go into places that are hard to reach typically around the world, Africa and Southeast Asia and South America, those kind of places where we want to have a presence, we want to give users a good viewing experience, but there isn't a whole lot of infrastructure to build on, so we need to accommodate to that. So our second piece here is our software. Once again, we're using very much industry-standard off-the-shelf pieces of software. We're using FreeBSD as our operating system. A lot of people say, why not Linux? And the answer is that we were able to hire a very talented team of engineers who knew how to use FreeBSD and knew how to squeeze most performance out of it. And that it also gave us the best opportunity for contributing our changes back upstream to the open source community so that other people could use it. Secondly, we use Nginx. It's been far and away industry leader in terms of performance and efficiency. And I'll talk a little bit about that efficiency here coming up. And then that's pretty much it. We have some housekeeping scripts that run, but we don't use any virtualization. We're kind of bucking the trend in the industry there as well, in that we're very much bare metal. We're going to squeeze the most performance out of the hardware as we can. But our system is very single use right now. It's just a web server that serves data from disk to the internet on demand.
So Scott, I heard a lot there, and I want to try to unpack some of the key points that you made. The first one I want to understand. So of that, say 33% of the North American internet traffic, you said some of it goes to AWS, some of it goes through your CDN. Is it fair to characterize that the majority of that 33%, 32.99% perhaps, is going through your content delivery network as opposed to AWS?
Yeah, absolutely. Data. So our command and control traffic is a super small percentage of that overall traffic. I don't even know. It's less than a rounding error type of thing. That 33% is really all the video traffic. And all that traffic does come off of our content delivery network, off of our machines. The data gets originated in AWS, gets encoded there, and then gets pushed out to origin servers that have been part of our network. So we're not actually streaming data from AWS at all. Gotcha.
And it is striking, though, that of that 33%, that the goal is to encrypt it all. I mean, if I don't know how far along that journey you guys are, but at least you have solved, I think, some of the core infrastructure problems of doing that. But I think it's quite striking that at that at that level of throughput, at that level of content delivery, that you're able to even contemplate this. I mean, this is something that would be quite a daunting challenge, I think, to anybody who has even much more modest bandwidth, basically considerations for the application.
Right, absolutely, and it's something that we talked about for a long time and kind of tried to grapple with ourselves, because it really is a big computational problem. Serving the bits is relatively easy. It's kind of an efficiency problem of getting things off disk and onto the network. But when you add in encryption, that's hugely computationally expensive. And the question was, do we buy, encryption accelerators? Do we try and buy host, more CPUs? Do we, lots of different options, and all of them look to be rather painful. So yeah, I'll talk about how we did eventually solve that problem and then optimize from there.
So one other point that I wanted to make, and I'm going to jump back a chart, is with your hardware environment, there were two things that really struck me, looking at this from a challenge perspective. One of them is that this hardware is embedded into those ISPs or internet exchanges, and then it's left there, for some life cycle, right? There's no maintenance to it. But that also means that there's probably multiple generations of this hardware, not just the current generation, but multiple generations going back years that are still out there, right? That are still serving content.
Yeah, absolutely. These are zero maintenance boxes. They're you can change out a power supply or a network optic port, but the disk drives are not hot swappable. None of the other components inside are swappable at all. These are really meant to be to send to an ISP or send to a remote data center and just have it run and just have it work. They are administered in software from a central point, but even then, that's highly automated at this point.
Mm-hmm. Now, how important, there's these multiple variables called out here. This, cost versus density versus reliability versus throughput. How do you guys grapple from the hardware side with finding that balance? Is there one of those that jumps out at you, or is it really about kind of trying to optimize all of them?
It's in a lot of ways it is about trying to optimize all of them. In terms of importance, especially when we're dealing with our ISP partners, a lot of times rack space and power is a big consideration. So we really have to optimize for that, and that's one of the reasons why we build our storage appliance to be so dense. Fitting in dozens of hard drives into a chassis, so that we can maximize that space, and we're actually working on further optimizing that from 4 U's down to 2 U's. And then, second is power, because we recognize that data centers are going green, and that power is a premium and it's a limited resource. So making these as efficient as possible in all those dimensions is very important to us.
I also had one question in your software, and that is, along the lines of using BSD or FreeBSD as opposed to some other, OS. Did that pose a challenge when you started looking for software to sort of tackle this, to tackle this challenge?
Nginx as our application stack was already well tuned for FreeBSD. There have been a lot of work done, a lot of history there. That company had a lot of experience with FreeBSD, so it was a natural pairing there. And as far as FreeBSD goes in general, it's kind of the silent workhorse of the internet in a lot of ways. It's doing a lot of the heavy lifting behind the scenes, and once we tapped into the right engineers, it was a very natural choice to go in that direction.
Yeah, it's kind of incredible that you guys as a team, are able to sort of be so small and lean and yet have this incredible impact. I mean, obviously, I'm a Netflix subscriber, and there's many, many millions of other people like me who are also subscribers. I think it's interesting. It's interesting to me just as a consumer to know that the team that actually put this this incredible infrastructure that effectively streams me all my movies. I can't remember the last time I got a DVD in the mail. That is such a small team. And I think it's really interesting to know that that you guys use open source and have that as a sort of core value. Can you maybe expand a little bit on that?
Yeah. So saying as a core value is a good way to put it, because like I said before, we're a very small team. We don't have the resources to manage a large software project from scratch all on our own. We really need to leverage a bigger community to help us with that. So, our engineering expertise is in areas of optimization and algorithms and that kind of thing. So by sharing our expertise and sharing our results and taking what we've improved and sharing it back to the community, the return that we get is that it builds a stronger community that then builds continues to build a strong, stable, effective OS that we can then draw back on. So it's this synergy, it's this circular ecosystem that we all benefit from, and it really is, like you said, it's one of our core values. It's one of the key things that keeps our organization running in this whole corner of Netflix is having such a healthy ecosystem there.
Gotcha. Now, you raised, I think, one of the key points of the rest of this talk, really, which is that your team specializes in optimization and really tackling the kind of the sticky and knotty challenges of pulling a solution together. In the next couple charts, I think you're going to talk about sort of the data path, how Nginx and encryption, how all of this kind of came together, right?
Yep. So let me go over to that. So the traditional data path that we were using with Nginx and FreeBSD used a kernel data path for getting data off the disk and into the network socket to go out to the client. This was part of Nginx's key bit of efficiency technology that we leveraged. It was well integrated with FreeBSD. And what this model did was it allowed the data to stay in kernel, never have to make that jump from kernel space to user space, which involves a copy, which involves inefficiencies in your CPU. And this worked really well for us for unencrypted data. We were able to reach 40 gigs with only some modest optimizations in the operating system to facilitate that. But then when we looked at doing encryption, we had to fall back to this model where the encryption is done in a user space library, which means the data has to go from the kernel into user space, be encrypted in that library, then go back into the kernel space to be sent out to the network. And then we were back to this really fairly inefficient model of inefficient use of the CPU resources, poor scaling. And I'll touch on that here in a few minutes on exactly what those numbers were and just how hard of a problem it was that we were facing. And I'll add that this is fairly technical charts here. We've myself and a colleague of mine have written some papers on this that are linked to on this presentation, linked to at the end, that our listeners can go read at their leisure and see more of the technical detail and more details on the results too.
So Scott, just let me interrupt real quick and understand, from a layman's perspective, right? Somebody who doesn't spend all day optimizing web servers, it seems that the really expensive piece for you would be that interaction between kernel space and user space. In other words, deviating from this sort of smooth, optimized path where everything really runs through the kernel and moving the data into user space for encryption. That's the, if you will, the problem.
Right. Making that transition across that horizontal line there involves a copy of the data. And when we're talking about doing 40 gigabits or 100 gigabits per second, that's a lot of copying that the CPU has to do. So it's taking considerable CPU resources just to do that. Not to mention that when you're in a highly parallelized environment, that there's other overhead that those copies invoke that creates a nonlinear scaling of your system.
And not to mention the actual encryption work itself. So, okay, that
right.
made sense. Thank you.
Right. So the idea that we had was, why do the encryption in the user space library? Why not just pull the encryption into kernel space too? And so that's what we pursued, and that's what our academic papers talk about is that process of retooling the web server, retooling the encryption path so that it happened inline in the kernel, no longer had to do that copy out, with things still operated securely and predictably. And the key there was that things like the command and control of the encryption still happens in user space, which is fine because that's a very small percentage of the amount of work to do. It's just the bulk encryption now happens in the kernel. So, and so we had this idea. We started implementing it, but with any big shift in thinking and big project like this, first thing you have to do is make it work, and you worry about the optimization later. And when we first went to try and make it work, our results showed that it worked, but didn't really show much of an improvement. using our storage appliance as our reference, where we could get 18 gigabits a second out of it. And when we talk about bandwidth, talk about 18 or 36 or whatever, just keep in mind for the audience that, these are 10 gig, 20 gig, 40 gig interfaces. We reserve 10% of the interface's bandwidth just to absorb any unexpected spikes and loads and that kind of stuff. So when we talk about machine being saturated at 18 gigs, we're using 20 gig interfaces, but we're just keeping that little reserve there. So with this graph, we were able to do 18 gigs unencrypted, but when we turned on encryption, we were only able to do 8.5. So it showed that it worked. It was a small improvement over going through UseWAN, but not the improvement that we were expecting. So that forced us to start looking at, are we doing something wrong, or is this an optimization problem? And that's where we turned to Intel for help, and that's where we started having this fantastic collaboration with them that we'll go into here. So the first big thing that we did with Intel is we got in touch with this team inside of them that works in a software library called ISAL. And Jonathan, do you want to talk about ISAL?
Of course, yeah. So ISAL stands for the Intelligent Storage Acceleration Library, and immediately many of you are thinking, what does storage acceleration have to do with content delivery and encryption? Well, what ISAL is a incredibly robust and high-performance library of this very, very fast optimized code for Intel CPUs. And while it does come from a storage slant, in other words, it's building some of the algorithms that are foundational to building storage devices, a lot of the things that storage devices are doing nowadays have much more to do with the things that other systems are doing nowadays. Things like compression and encryption, hashing, and so on are, of course, foundational to different storage use cases, but certainly have broader implications beyond just storage. And the reason I think that this is, it's a tremendous collaboration from our perspective is that when Netflix, when you guys came in for a briefing, when you saw this, you sort of almost passed on even getting briefed on this library, right? You didn't really want to necessarily spend the time from a scheduling perspective. But someone within your group, and Scott, maybe I tip my hat to you on this one, decided, hey, let's hear these guys out. Let's hear at least what they're talking about, hear the work that they're doing, and see if there's anything of value there for us. And I think certainly there was, right?
Yeah, absolutely. And that's exactly it. This was pitched as a storage acceleration library, and as we were listening to the pitch, kind of dawned on us that this could apply to network as well. That the encryption that's happening in the storage is the same kind of encryption that we need to do on the network side. So we posed that challenge to the ISAL team. We said, could this work for networking? And they kind of looked at each other and said, yeah, it probably can. So from there, we were able to take their libraries and substitute them into our existing infrastructure and data path, and with relatively little work, drop them in and start running them on the network side.
Now, Scott, I do have one quick question for you, and that is, you talked earlier about 40 gig, and then you said, well, we reserved the last 10%, so our 40 gig lines are really 36. In this case, it's 18. Is this a different system config than you were talking about previously?
So this was using a storage appliance, which we kind of use as a baseline to work with because we had so many in our lab, so it was just kind of an easy target to start working with. Also, since we were starting with such low performance to begin with, we weren't even thinking about 40 gigs yet. We were just trying to see if we could get to 20 gigs with encryption. So yeah, that's a great question, and we'll go into where this scaled from. The storage appliance that was only able to do 20 gigs up forward here in another slide or two. But the key takeaway here is that by using Intel's technology in a little creative way, we were able to achieve very quick results, very impressive results, very, very quickly. So
yeah. Now, how about the problem to get to 100 gigs? Because this is the first goal that you introduced, right? This was the challenge for you guys was to get your architecture optimized for 100 gig. Then it was adding encryption, right? Which is quite a curveball to add. But can you share a little bit of the results there and how that worked?
Right. So we were actually doing kind of both projects of 100 gig and encryption in parallel because the technologies were both kind of emerging in the market in parallel. So we had one sub team that was working on 100 gig, and to do that they turned to latest Intel E5 processors, NVMe storage, because that NVMe is just so fantastically fast now at taking data off a disk and putting it into host memory, and doing it at a cost-effective and storage-dense way. So we switched to NVMe. We switched to the latest Xeon processors, and we were able to get to 100 gig relatively easy that way. But then the next step was, how do we start encrypting that? Since we had success at 20 gigs of encryption, how do we scale that out to 100? So when we did this, our 100 gig. So when we first turned on encryption without the ISA libraries, our 100 gig box was only able to do 26 gigs. When we added in the ISAL libraries into our encryption path, it jumped up to 58. Fantastic increase, practically 2x increase, but it still wasn't all the way there. So we went back to Intel and posed the next challenge to them of, how to get from 58 up to, 90/100. What tools do you have? What other tricks do you have up your sleeve that we could use? So first to answer the call with the ISL team, they looked at our results. They looked at some of the data that we were generating for debugging and for analysis, and they came up with some improvements to the library that got us another almost 10%. And what was so amazing was that this happened over a week or two period, between getting a hold of them and sharing with them our results, and then coming back with something that worked. A very short period of time. They were really happy to work with us. They were really open about it. So it just really strengthened that collaboration that we had. So then at the end of that, we were at 65 gigs, which was very respectful. We're at 2/3 of our goal. And we're actually pretty happy with ourselves, but we still wanted to see how far further could we take it. The next answer to the call was the VTune team, and we worked with them over a couple months on integrating VTune into our tooling so that we could do analysis, and working with their expertise on how to interpret the results and go from there. And using that tooling and using that expertise, we were able to reach up to 76 gigs. This chart actually kind of combines two bars together here, but we were able to get to 76 gigs, which, fantastic. Now we're at 3/4 of our goal. And the last step was realizing that we've actually run out of memory bandwidth at this point. Our platform is single socket. It's not dual socket. And even populating all the memory channels, we were running out of memory. So the last step was using a couple more Intel tools, the memory bandwidth tools, PCM, and realizing that we were reaching memory bandwidth, and then from there taking that to our memory vendors and saying, you got to need faster memory for us. And by having that insight using the Intel tools and being able to take that to our vendors, we were able to get some faster memory that got us up to 83 gigs.
Right. So this is just an incredible software story. From my perspective, it is it's incredible that a single socket server can even do this. That's pretty impressive. when you mentioned earlier, and I think perhaps we should get you in touch with Intel's marketing and branding people, because I much prefer the term super beefy server to any of our Intel marketing names for stuff. But that aside, I think it's actually quite impressive that between the agility of your team coming back to the ISAL team saying, hey, we need this tweak, and it was as you say, it was a collaboration. You guys were very explicit with, we think that this might have value. Our chief designer and tech lead took that input, made the change, and turned it around within a couple days, basically to try to make sure that hey, does this assertion hold water? And certainly it did. And so we were able to get you that fix, for this specific use case very, very quickly. That would not be the case if hardware was involved. Turning hardware is obviously not something you can do in 2 or 3 days.
Right.
The last
one of the
piece,
beautiful
though.
things,
Oh, go ahead.
Oh, go ahead. I was going to say, one of the beautiful things about the ISAL library is that it didn't require just the latest Intel CPUs. It actually has modules that take advantage of features of previous generations. So this went back to one of the original goals of being cost effective. We didn't want to go and rip out all of our existing infrastructure and replace it. These libraries just dropped in, and even with some of the new optimizations that were done, that all applied to even our older hardware.
That's a crucial point. You probably can't talk about that one enough. The fact that you could take this software, deploy it through your normal channels, and suddenly start seeing really capable encryption performance out of even boxes that were 2 and 3 and 4 years old, stuff that was designed and built before this requirement came out. That's a very notable fact that you guys were able to take advantage of.
Yep, absolutely. It worked out great all around.
Well, spectacular. Now, Scott, I want to talk through, the bottom line numbers, right? You got a huge, 300+% improvement just tuning the software here, which is pretty incredible. But beyond that, if you look at these results, look in these two systems, basically the bars here are showing that performance with each of these refinements applied to do different generations. One is circa 2013, and one is circa 2016, right? 2 different CPU architectures, different network architectures, and everything, but the same software enhancements applied to both, right? And it's these charts are a little bit skewed, I think, from being imported into this tool. But I think what you can see is that chart on the left, you can actually fully saturate the line rate, or your capped line rate at 36 gigabit per second with encrypted data. And on the right, you're 8/9 more than 8/9 of the way there. To fully saturating that network link. And again, that's just incredible results for not having any dedicated offload, for not having any dedicated hardware beyond a single socket system. That's just amazing.
Yep. And, as a side note, when you talk about offload, we did architect systems that could make use of offload as new features are added to future generations of CPUs. If acceleration, kind of offload onload acceleration becomes a feature in the future, we can take advantage of that and run that side by side with the ISAL libraries. So this is architecture that will grow with the platform going forward. We're really excited about that.
Nice, that's fantastic. So you viewers of the webinar here, what should you take away? The first is, that Netflix as a team, they blazed this particular trail out of necessity. They had a business challenge that was, quite daunting, and did the fundamental research to compare all the solutions. I mean, if you go through those charts, you'll see that and those papers that are linked here, you'll see that they compared OpenSSL and Boring SSL, ISAL, and a number of other different solutions to try to solve this problem. The fact that they're willing to not just do that work, but also to share it, I think is quite quite outstanding. And the last one, I think, Scott, to the point you were maybe just making or alluding to, the business outcome, right? What did this mean from a dollars and cents perspective? When you started, it looked like it was going to be, cost prohibitive to do this, right?
Right. It was going to be, maybe 3x more compute power, which meant, basically a 3x increase in our build out, which is, significant, both in terms of money and also in terms of, like I said, space and power with not only our data centers but our partners, and that was going to be prohibitive. And now we've compressed that down to being a very small percentage of overheads, and that is part of our normal growth pattern and growth projection to begin with. So that 300% is collapsed down to almost nothing.
Yeah, it's spectacular. That's incredible. So for people that are listening, taking notes, what should you take away from this, right? Software encryption, just in this example, was once a tremendous and monumental challenge. It was, if you will, climbing Everest to do software encryption at 100 gigabit per second line rate. However, even these monumental challenges are solvable with the right tools. If you put together the right tools, if you have the right team, like Scott has assembled at Netflix, you can do it, even if it seems incredibly challenging. Now, Intel, as a company, makes an incredible array of different tools like ISAL, like VTune, which is the other one that we alluded to in the call, which was crucial for the sort of final tuning of this software. There's an amazing array of tools that Intel makes, not just in the storage domain, not just in the network optimization domain, but really across the board, from machine learning to media processing. And it's really important, and if you take nothing else away, it's really important that you engage your respective Intel account teams, right? Bring your challenges to them, and they should act as your guides. In this climbing Everest analogy, they're the ones that not only know the paths to get up the winding mountains, but they can also tell you, hey, this set of tools, you wouldn't try to climb Everest in flip-flops and a t-shirt. You probably need some pretty decent gear to make it up. And the Intel folks have a really good knowledge of the actual tools that are available, the ones that we can equip you with, and why those make such a big impact on these challenges. And so, again, if there's nothing else, I'd like to say thank you very much for the time, and point you as interested parties to a set of links here, and I'll leave these up, and they'll be also uploaded in the attachments and links section in Bright Talk. So if you want to read more, if you want to follow up, if you want some nitty-gritty details, right, you can definitely read any of these to get more information. Katie, I'm going to hand it back to you. Are there any questions from the audience?
Yeah, thanks so much, Jonathan. This has been really, truly very fantastic and informative, and I would love to get to some of these questions that came in our last few minutes we have here. Let's see. So first we have, is it safe to assume that ISAL is supported on FreeBSD, Linux, and Windows?
Well, that's a very good question. So FreeBSD is not the only OS that ISAL supports. So ISAL is low-level assembly, and that has kind of three big side effects. The first is that it's really, really fast, right? These are extremely fast, highly optimized libraries to do whatever it is that they do, as well as Intel processors can do them, right? That's one. Two is that it's OS agnostic. Because it's assembly, it kind of lives below the level of the OS awareness. That's really crucial. That means that you can use this on FreeBSD, on Linux, on Windows, on more esoteric operating systems like VxWorks. Literally just about anything that runs on an Intel CPU can run an ISAL library. So even if you're building your own OS, I mean, for the really deep tinkerers out there, it's certainly something that would enable that.
Perfect. Let's see. So we also have, what are the other broad applications for ISAL beyond encryption?
Yeah, that's a good question. So ISAL is because it's, first of all, we didn't talk too much about this. We should have. ISAL is BSD licensed, and BSD and FreeBSD both have this incredible shared point of licensing, which puts them in sort of contrast to some of the other OSs that are out there. And that is, you can take this software and use it in absolutely anything. There's no licensing cost. We're giving it away. We're even open sourcing it so people can make improvements if they would like to. And not only are we giving it away, but we're saying you can use it in something commercial, you can use it in something open source, wherever you use it, right, is going to be fine. So to that point, ISL has this incredibly broad applicability, and I think that it's very, very nice to be able to have this level of software and tuning and performance for not only zero cost, but with maximum flexibility. And Katie, I kind of pivoted away from the question. What was the actual question? I'll try to answer it.
We were asking, let's see, what are other broad applications for ISAL beyond encryption?
Oh, sure. Yeah, so ISAL, it really has 5 categories of software to it, right? There's data protection and data integrity. Those are obviously central to storage devices, doing data protection stuff like RAID or erasure coding, and data integrity stuff like CRC checking is sort of part and parcel to every storage application, whether that be software or hardware, right? And then there are things that are perhaps more broadly applicable, things like encryption, right, that Netflix used, things like hashing, both cryptographic and otherwise, for any circumstance or situation where you might need to fingerprint some data such that you can uniquely identify it. And then also, and that's by the way is one of the fastest, the areas in which ISAL is its delta compared to anything else on the market is the biggest. It's huge, like 10, 15 times faster than OpenSSL. That said, there's also the compression piece. We've spent a lot of work this year rewriting our compression libraries, and so we have a deflate algorithm, which is a so-called zip or zlib compression algorithm, and it's extremely fast, something like 5 or 6x faster than zlib, and so that might have some broader implications as well beyond just the storage domain.
Awesome, great. Thanks for clarifying that. So I really love this question, you guys. What is the next big challenge for the Open Connect architecture team?
We always love challenges. Looking forward, it's 200 gigabit, 400 gigabit, terabit networking. How do we scale up to that? It's also looking how do we scale down even further. I was talking about the global appliance that's meant to go to small areas, not small areas, but areas with less internet infrastructure. How do we continue to make that more efficient and continue to provide a very good product, a very good service to our customers. It's looking at, how do we deliver higher quality video bits, higher definition and crisper images over the same infrastructure. So there's always growth. There's always new things around the corner that our customers are interested in. There's always opportunities to make our platform more efficient and easier to operate and cheaper to deploy. So it's kind of a broad stroke where we're going.
Great. And it looks like we have one more kind of circling back to our ISAL and this collaboration. So are you planning to push this Netflix and Intel code upstream somewhere? And along the same lines, can ISAL be incorporated into open source projects?
Oh yeah, those are good questions. Yeah. So Scott, maybe you can speak to the upstreaming piece.
So yeah, for upstreaming, we are in the process right now of taking our improvements and working with the FreeBSD community to get them upstream, get them to be made generic and acceptable to all stakeholders involved. That process is ongoing, and some of the improvements are in FreeBSD upstream right now. We're also in the process of taking the ISAL libraries and packaging them up into kind of self-contained extension libraries for the OS that can be downloaded and dropped in. And Jonathan, you might be able to talk about availability of ISAL from Intel.
Yeah, sure. So with respect to OpenSSL specifically, there's nothing in the license that prevents people from using ISAL in any open source project. So that's definitely on the table. But with OpenSSL, ultimately, a lot of the improvements from a Cypher perspective can find their way into projects like OpenSSL. So there's similar teams to the ISAL team that are working to optimize OpenSSL and other open source projects for IA. And so while ISAL might sort of pathfind some of that work, perhaps eventually much or all of it should find its way into things like OpenSSL. Now, whether that's compatible with a given application's data path, right, is a whole other question. And the reason that ISAL is part of why it's so wonderful is that it is very low level and granular. It doesn't try to do a whole lot of things. It tries to provide the absolute best performance for this one little specific thing that it does. So if you're making a data path or performance path like the Netflix guys here, they had the ability to take just this one piece, the cipher encoding, the bulk encryption piece out of ISAL and use it and put that into their data path.
Perfect.
Yeah, those are good questions.
Yeah, so we've wrapped up our questions portion here, guys. And so Jonathan and Scott, thank you so much for this incredibly informative and outstanding presentation. We really appreciate you taking the time to talk with us today. And to all of our viewers, thank you, and we hope to see you in future episodes of Data Center Insights. And just a reminder, if you haven't subscribed to our channel already, you can do so from the main Data Center Insights channel window. We'll also work to getting some of the attachments referenced today up for you after this webinar has ended. And we hope to see you at future webinars. And until then, be well and have a great day, everyone.
Thanks, Katie. Thanks, everyone.
Bye-bye.
Thank you.